So in this video we're going to be using the law of cosines to solve a triangle with two sides and an included angle. So first, before we go over the formulas, let's just talk about what it means to have two sides and an included angle. So let's look at this triangle here. I have this side. Okay, this is side B. And I also have this side, which is side A. So you can see angle C is like kind of right in the middle. Side B and side A come together, and angle C is right in the middle. So this is what it means. We have two sides and the included angle. So the included angle is kind of the angle that's right in the middle. And in this case, we can't use the law of sines, but we can use the law of cosines. So I want to come back to these formulas. Now, this first set of formulas up here, you can see is written to solve for a specific side. Okay. Now below, the formulas are written to solve for specific angles. And in this video, we're going to stick with the side measures. In the next video, we'll work with solving an angle with the law of cosines. But a couple things to say about these formulas. You may be asked to memorize them. They're not that hard to memorize. So let me talk about the structure. So we have a squared equals b squared plus c squared, and then subtract 2bc cosine a. So you can see there's a little bit of symmetry in this. We've got A, B, and C, and then when we subtract, we have B and C right together there, and then the final angle kind of matches with the first side, and you can see that pattern remains. So the next one is we solve for B. We have B squared. It finishes with angle B. In the middle, you got A and C, and then A and C come together again. The last one, solve for side C. It finishes with angle C. You've got A and B together here, and B squared. So the reality is there are patterns, and if you have to memorize these, I would recommend just to write them down 3 or 4 times, and just remember that those little patterns which I was talking about, and I think you'll have no trouble memorizing them. So we're going to go ahead and solve the problem below. So first and foremost, let's look at this triangle. We're asked to solve for side C, so that's going to be right out here. And I'm going to go and pick the formula which we need from the top. So that's c squared equals a squared plus b squared minus 2ab cosine of c. Okay. So I think the way to go about this is to go ahead and we take a square root of both sides. So now I'm going to go ahead for A. A was 18, so this is going to be 18 squared. B was 27. And then angle C was 83. And here, certainly you got to move into your calculator. But I'm going to put several steps on here, and you may wish to just combine it into 1 or 2. But this whole thing I'm going to do with one calculator operation, and that's going to be 118.4. Okay. So then I have C is the square root of 934.6. We set around to 1 decimal place, so that's nearest tenth. So this comes out to 30.6. So I recommend to follow along with that. Make sure you're able to get the exact answer, and then you're finished with that part. 30.6. So the next part of this question that says to solve for angle A and B. Well, at this point, now that I've got this pair with angle C, and side C, I can just use the law of sines. So I'm going to solve for angle A. Let's get back to my trusty blue color there. Angle A. Okay, so I can say the sine of A, which is what I am trying to solve, over side A equals the sine of C over side C. So we'll just move back to this familiar pattern, but let's go ahead and fill this in. So the sine of A, I don't know angle A, but I have side A, and then sine of C over side C. Okay, so what I can do, I can do this in one step. If I multiply by 18 on both sides, it's going to give me this. So if you didn't catch that, you may want to go back and look, but it's always helpful to find faster ways to do these. I just multiplied by an 18 on both sides. Now I can finish this with just one calculator operation. So I'm going to have the sine of A equal to 0.58. So angle A is going to equal the inverse sine of 0.58, and angle A is going to be 35.5 degrees. Okay, so now let's look back at the triangle. So 35.5 and last thing, let's go ahead and get angle C. I'm just going to squeeze this in up here at the top. So we'll have 180 subtract 83 subtract 35.5, and I'm sorry, that's not angle C. We already have angle C. This is for angle B. Okay, so angle B is 180. We're going to subtract off 35.5, and we get 61.5 degrees. So 61.5. Okay, so triangle is solved. We have all the sides, we have all the angles. Okay, so that's law of cosines. Two sides in the included angle. We only needed to use law of cosines to get side C, and then we're able to use law of sines to go back and solve for the rest of the triangle.